Hi class, my name is Young and I am the instructor for database development. I am very excited to be here and to be able to share my experience with all of you. Well, let's get started. What is a database? In my opinion, a database is simply a data storage that you use to store data and define how the data can be accessed. Those are the two key components or ideas that I would use to describe what is a database. Again, it is how can you store the data on the database. Secondly, how you can access data for that database. Back when software development or database technology really emerged, we have the flat file system. Flat file system literally mean that you're going to store data into or onto a specific file. That file can be a text file, that file can be a cassette, can be a tape, can be a CD, whatever. All of those are examples of flat file data storage. For flat file data storage, you generally have 3 to 4 different data structure that you can use for flat files. And let me switch here. I'm not going to go through every single slide on the PowerPoint. I'm just going to cover the material that I believe will be useful to all of you, right? Because this is pretty much for academia purposes, but my goal is to both teach you what database is, how to write SQL, and what is currently being widely used by most corporates. Again, for flat files, you have different data structure that you can use. The first one is the sequential files. What sequential files mean is that you have to store data sequentially. The data will be sorted when you use sequential flat file data storage. If you have 5 record number 1 through 5, then record number 1 will go first, then 2, then 3, then 4, then 5. They are sorted in that order. It is pretty bad to use sequential file because if you want to access a particular record, say if you want to access data record number 6, then you have to traverse from data record number 1 all the way through data record number 5 before you can access data record number 6. Index sequential files is the algorithm or is the mechanism that allow you to store or to group a collection of data with similar characteristics together. Meaning, if for all data that describe a student, age, class, school, hair color, eyes color, they are considered data with similar characteristics, and so they should be grouped together. Whenever you group a collection of data together, you're going to store them onto what is considered a block. That is a block of data. That block of data will be stored randomly throughout the disk that you have. And if you want to access a specific piece of information about a student, say you want to get back their student age, right? Then the first thing you have to do is identify where is that block of data that describe the student is on the disk. To do that, you would have the index. The index basically describe the position of that data block on the disk. If you have the index, then all you have to do is provide the index to the disk, and you would be able to access that entire collection of data about the students. The bad thing is that once you get back those collection of data, you may have to traverse through all the other data before you can get back the age of the student. Now, for that student data block, if the data that illustrate how old the student is the first data in that block, then you are in luck. You no longer have to traverse through anything to find it. But if it is located at the very last position in that data block, then you have to traverse through all data before that, before you can access that piece of information. For direct files are extremely similar to index sequential files, because a direct file just means that you still have the index and you still have data block. The data block will still be stored not contiguously, uncontiguously on the disk, meaning they're not going to be stored continuously, they're going to be stored randomly throughout the disk. But if you know the index will take you to the actual location of that specific piece of data that you want to access. If you want to access the age, then you're going to have the index that will point you to where the age is stored on that data block. Okay, because those flat files were the very first data storage technology that emerged, obviously they're going to be pretty limited. What I mean by that is that they limited because their number one disadvantage for them, in my opinion, is that they are very system dependent and they don't allow for any data sharing to happen. Flat files is system dependent because usually that you only need the flat file to support one system. Say for example, if you operate a restaurant, right, then you may not want to spend money to create the actual database system because it will be expensive, since you need like an actual environment. Usually it's a server where you can host the database. You also need the hardware. Hardware is very expensive, right? Then you may also need to have other backup strategy required in case a disaster strikes that can cause you to lose data. So flat file is useful because flat file is useful for those situations where you have like a small business and you're not gonna expand your business just going to stay in one location. Then chances are you may want to use a flat file because you can save a lot of money on them. But again, if you only have one single restaurant and you decide to use flat file as your data storage mechanism, then that the file may have all information about the finance and the operation of the restaurant. But if you decide to expand your business and open another restaurant, that means you're going to you're going to have to replicate whatever system and data storage you have already configured for your first restaurant at your second restaurant now, right? Meaning now at the second restaurant, that system that you configure at the second restaurant will also have its own flat file. Though you have two restaurants, two same data storage mechanism, but two actual data storage, which is the flat files. The system at restaurant 2 will never be able to access the data storage produced by the system at restaurant 1. And so if you want to conveniently get back both finance or operation data for both the restaurant, see if you actually making any profits, or if you want to expand your business, you will not be able to do it conveniently. You have to literally go through the flat file at system 1 first, and then go to restaurant number 2 and access the flat file and get the data from there in order to and combine them manually in order to do any sort of analytics. That is very inconvenient, and that is where you should, instead of choosing flat file technology, you should choose the more modern database management system. As I have just previously mentioned, database management system is preferred over flat files because of these benefits: data sharing, program data independence. I think those two are the major arguing points that you should use if you decided to use an RDBMS system. Excuse me. I apologize. I needed some water. Sorry about that. Now, back to the advantages of a database management system. they support data sharing, and they support program data independence. What database management system is that you have one dedicated centralized place where all the data will be stored. So even if you expand your business to restaurant number 3, restaurant number 4, restaurant number 5, all of the system at those restaurants will just need to establish a connection or being able to access the data storage that you have created for all of the system to use together. At that point, it's pretty program independence because you won't have a different data storage for every system anymore. You simply have one data storage that is used by all the system. Program data independence is what really allow or enable for data sharing to happen. Now you could easily or conveniently perform data analysis on the operations of all the stores that you have and decide whether or not you want to expand the business, how the business is doing, make whatever informed decision you want to make. The disadvantage of using an Excel database system is that you're going to need pretty expensive hardware. Now they are not cheap. An Excel database system is a lot more expensive than a simple cassette, tape, disk, or USB. You're also going to need to have dedicated machine or server where you can host your database on. What that means is that machine or that server is what enable for all the restaurant system to be able to talk to your database. All they have to do is establish connection to that host, and then they can access the database that you have on that host in order to get back whatever data that they need or to store any data into that database that you have set up on that machine. Another thing that you have to keep in mind is that you're going to need some really good data backup strategy or data redundancy, because since all systems going to use the same data storage, if there is a nature disaster occurred, right, and somehow unfortunately strike your database, it brought down the entire data storage system, all the restaurants will not have any other places to store data. And so if their customer in there paying you money or cash, you may not have a place to capture that information, and those are revenue that may be lost forever because you did not capture them anywhere. And that's why you need good data backup strategy or data disaster recovery plan. Some pretty good is you're either gonna have 2 databases constantly running, and one database could be the active database system, while the other one would just be a backup. Right? You can then probably take backup of the database that running once a week or maybe once a day to the backup database that you actually have, so that if any nature disaster occurred, you can promote the backup database to become the actual active database that all the restaurant can use and continue to store data or to access whatever data they need. That will allow for the business to continue run instead of having to disrupt business continuity, right? For database management system, similar to how there are multiple data structure for the flat files, DBMS or database management system also have 4 of them. The first one is the hierarchy model. This model was developed by IBM company. They have a pretty well-known system called IMS, which is their database system that was developed using the hierarchy model. What if you say IMS? Not many people may know about it because it is the very early introduction of database management system. Instead, you can call it mainframe. Mainframe is the industry term that is used to refer to the IMS database system that IBM has developed. For the hierarchy model, the data is basically stored as a binary tree model. A binary tree is basically, think of it as in a tree, and you would have the root node. Whatever that node is, it can possibly have up to 2 child nodes spawned from that node, and then each child node could then become the parent node and continuously having 2 more child node spawned from them. That's the hierarchy model. Is surprisingly though nowadays, because relational model, which is I will explain in a minute, relational model nowadays is so popular. Almost all database that you will be dealing with are guaranteed to be the relational database management system, or if you hear RDBMS, that is referred to the same thing. Also, if you hear DBMS, in the majority of cases, that's still referred to RDBMS. So whenever you go work for a company, you may hear the term legacy system. Legacy system more than likely going to refer to the IBM IMS database system, because company, right, especially non-technology company like Home Depots, Lowe's, UPS, they need the technology to support the business, and so they are pretty resistant to change. They're not willing to adapt. That's why changes are very, very slow in those companies, and that is the exact reason why a lot of companies still use mainframe database, because simply it's going to take a very, very long time to migrate from mainframe into RDBMS system, and that is why you're still going to see mainframe being used even in this day. For relational model, that is the most popular DBMS system. Relational model for data structure I'm sorry, is pretty much just a table where you have columns and row. It's a two-dimensional table where the column define the type of data that you want to store. For example, you may have a table that is strictly dedicated to store student information. So you may have columns such as student first name, student last name, student age, student number. The row is the actual record for that for one student. Right, so again, column is the type of information that you want to store. Row is the actual data that you will be storing. You also have object-oriented database system. What this means is that instead of using the table structure where you have the two-dimensional table, object-oriented store everything as an object so that you can interact with them directly in the code. This is useful if you only want to have one data model, or if you need to really have high performance machine. Think of object-oriented database system as a car engine. Whenever you turn on your car, a lot of different system has to run, like the radio system has to run, the radiator, the steering wheel, the tires, the brake, everything has to run. Each of these could be an object, but they work together to form one master object, that is the car. Right, so object oriented just means that you're going to store your data in an Excel object instead of in a table. And it is very useful if you have taken any programming classes. Then you will hear about object-oriented programming. In object-oriented programming, one of the key features of that is inheritance, meaning you can have a parent object with, say, hair color, height, eyes color, DNA, blood type, and you can also have a child object that directly inherit all the attribute of that parent object. So when you have the child will automatically inherit all those attributes such as hair color, eyes color, the height, the blood type. You don't have to redefine those attributes for the child. The child automatically inherit those attributes from the parent. You cannot do that with a relational model. A relational model strictly means you're only gonna store data in a table. You may have 2 or 3 or 4 tables that are associated together in order to inform about a relationship. But for object oriented, you can have the Excel object that already have all the relationship defined for you. You simply just have to access them and use them. And that's really all I have for database system. For the purpose of this class, we are going to spend a lot of time learning about relational database management system. Right? Whenever you hear relational database management system, nowadays, when you hear that term, people generally refer to, hey, who made the system that you are using, right? And some of the big vendors names include, some of the big vendor name are Oracle database. You also have SQL Server. You have Teradata. You also have MySQL. All of them are relational database management system, right? And what you would also learn from this class is the new type of database environment, which is NoSQL. We're not going to talk about it today. We're going to have a lecture dedicated to NoSQL, so you know what NoSQL is. But for the purpose of this class, our focus is going to stay with relational database management system. I'm actually going to write a tutorial of how you can install Oracle database onto your machine so you can do your assignment on there. Whenever I finish it, I will post it up for you guys to follow and install Oracle onto your machine. But for this week, just focus on reading the note and the PowerPoint slides that have been posted onto your week 1 content. If you have any questions, feel free to post them in the discussion area. I review them at least once a day, and if you have any question, I will answer them for you. Make sure you understand it. Alright, let's learn the class together. Thank you.